In this video, we will do several application problems that end up being quadratic equations. For our first example, let's assume we have a picture frame that measures 28 centimeters by 32 centimeters and is of uniform width. What is the width of the frame if 192 cubic centimeters of the picture shows? So as is always the case with an application problem, it's a good idea to identify your variables. And in this particular case, I'm going to do that on a picture so that I can understand what's happening. So I have a picture frame, and I know that it is 32 centimeters by 28 centimeters. Here's the frame. We're also told that the picture inside is 192 centimeters squared. And we want to know, what is this width, this little width here, and it does say that it's uniform, so we're going to call that our x. All right, so we have our picture, and we have identified our variables in our picture. X is the width of the frame. All right, so let's read the question again. I often find that I read a problem 2 or 3 times before I'm done. A picture frame measures 28 by 32 and is of uniform width. What is the width of the frame if 192 centimeters of the picture shows? So I need to know what this width is and what this width is. I know the outside, but I don't know the inside. So if this is of uniform width, x, then this top should be 28 minus 2x, the x from this side and the x from this side. And similarly, this width should be 32 minus 2x, because we're taking this x from this side and this x from this side. So the rectangle in the middle has an area of 28 minus 2x times 32 minus 2x, and we're told that that area is 192. So I'm going to FOIL this. 28 times 32 is 896 minus 56x minus 64x plus 4x squared. These are like terms. So we have 192, and I'm going to go ahead and write this in descending order. So 4x squared minus 120x plus 896. And you can see we have a quadratic, and very often, most often, when we solve a quadratic, we set it equal to 0. So I'm going to subtract 192 from each side. All right. I don't know about you, but I notice immediately that these are all divisible by 4. So I am going to divide through everything by 4. That's going to make my numbers smaller. X squared minus 30x plus 176. And I'm hopeful that this will factor, and it does. Two things that multiply to 176 that add to 30 are minus 8 and minus 22. So I'm going to do x minus 8 and x minus 22, and so we get x equals 8 and x equals 22. So this is a good time to talk about the domain for an application problem. What kinds of things make sense? Well, if x is 8, can I do 28 minus 2 times 8? I certainly can. And 32 minus 2 times 8, I can. However, if x is 22, 28 minus 2 times 22 would be a negative value. So in this particular case, x cannot be 22 because it's too big of a frame to make the 28 centimeters and the 32 centimeters. So the width of the frame, and we always answer in a sentence, is 8, and we want to make sure we use our correct units, 8 centimeters. For our next example, we're going to look at a falling object. We have a falling object that travels a distance given by the formula d equals 5t plus 16t squared feet, where t is measured in seconds. And the question is, how long will it take for the object to travel 74 feet? So we want to know, when is the distance 74? So in for the d, we're going to put 74. And you'll notice that we have a quadratic. I'm going to write our quadratic in descending order, 16t squared plus 5t, and then I'll subtract 74 from each side, and it will leave me with 0. So we have a quadratic here. I notice that it does not have any common factors, a greatest common factor. And I also notice that 16 times 74 is going to be really, really icky. So when I look at this, I'm going to use the quadratic formula. If you don't have that memorized, you should. And we're going to say t equals negative b, so negative 5, plus or minus the square root of b squared, so 16 squared is 256, minus 4 times 16 times negative 74, all over 2 times 16. So using our calculator, we get negative 5 plus or minus the square root of 4,992 over 32. And because we're talking about time, I don't believe this is a perfect square. I'm going to round to 2 decimal places. It's 70.65. And then let's consider both of these. If I do minus 5 minus 70.65, this is going to be a negative answer for t, and t is measured in seconds. Time can't be negative, so this one doesn't really give me anything. The other one is negative 5 plus 70.65 over 32, and we will say that that is approximately 2.05 seconds. So then we will write a sentence that says the object travels 74 feet in 2.05 seconds. Okay. Our next example here is another rectangle. In this particular case, we have the width of a rectangle is the length minus 4 units. The area of the rectangle is 12 units. What is the width in units of the rectangle? So again, I'm going to write a rectangle here, and I'm going to say this is my length and this is my width. And what we know is that the length, the width, W, is the length minus 4. So we could write that down here, length minus 4. The area of a rectangle is length times width, or in this case, length times length minus 4. And we know that the area is 12 units. So we have L squared minus 4L. And if I set that equal to 0, it conveniently factors. Multiplying to 12 and adding to negative 4 would be negative 6 and positive 2. So we would get the length is 6 or negative 2. And again, in the context of the problem, a negative 2 length does not make sense. So we could say the width of the rectangle is, okay, this is the length, so we'll just plug that in there. 6 minus 4 is 2, so 2 units. Okay. Let's take a look at this next example. Let me block this out. That's for the next video. We have when 10 is subtracted from the square of a number, the result is 3 times the number. Find the negative solution. So let's identify our variable. Let n equal the number. So this says when 10 is subtracted from the square of the number, n squared is the square of the number. So if we subtract 10 from the square, the result is 3 times the number. This one's pretty straightforward, but I have identified my variable here. I am going to subtract 3n and put this in descending order. So 2 numbers that multiply to negative 10, 1 and 10, 2 and 5, I think negative 5 and positive 2. And we'll get n equals 5 and n equals negative 2. And if I look what it says find the negative solution. We're going to say the negative solution is x equals, oh, not x because we didn't use x, right? N equals negative 2. Okay, that concludes this video on applications that can be solved using quadratics.